Hello, this is Tony. I'm a math, physics, and chemistry tutor here at OpenWisdom Education. Today, I'll be going through 3 multiple choice from the 2020 HSC Physics paper. Have a look at the first question, question 9. Bohr improved on Rutherford's model of the atom. Which observation by Bohr provided evidence supporting the improvement? Feel free to pause the video now and have a go at the question yourself. Otherwise, I'll be going through the solution now. We know that Bohr and Rutherford's model have been discussed in Module 8 from the universe to the atom, and we know that relevant dot point would be assessing limitations for both. This would help us understand what the question is trying to ask. Let's remind ourselves what each of the model look like. Rutherford's planetary model have proton in the center with electrons surrounding it, whereas Bohr's model suggesting energy shells for electrons to exist in. We must understand where each of the model came from and the certain limitations to understand what the question is trying to ask and what the answer should be. We know that Rutherford's model came from Geiger-Marsden's gold foil experiment, and the certain limitations are that it did not explain composition of the nucleus, it did not show arrangement of electrons, and also did not explain why electrons don't accelerate and fall into the nucleus. With the limitations in mind, we know what Bohr has worked towards to solve the limitations, and that's through looking at the hydrogen emission spectrum. His quantum mechanical model of the atom has 4 postulates, with the most important one being the discrete energy levels. We can also consider relevant limitations to the model. Let's have a look at the options from bottom up. D, a beam of electrons reflected from a nickel crystal. We know that this is not talking about any of the experiments that led to the models, so that D can't be correct. C, a small percentage of alpha particles fired at a gold foil. This is talking about Geiger-Marsden's experiment, which is also incorrect. B, the collision of an electron and a positron. This is already beyond what each of the model have covered, so that B can't be correct as well. Which led the final answer to be A, elements produce unique emission spectra consisting of discrete wavelength. So this one talked about Bohr's observation from hydrogen emission spectrum, which led to his model with discrete energy levels. And this answers what the question is trying to ask, which then this is the correct answer. Question 12. In which of the following would the satellite have the greatest escape velocity from Earth? So this is evidently from Module 5, Advanced Mechanics, and it already told you what the relevant dot point would be. It's escape velocity. What is escape velocity? We know that it's the minimum velocity required for an object to escape the gravitational attraction of another object, such that it will no longer be impacted by the initial field. In this case, the satellite is trying to escape from Earth's gravitational pull. Let's have a look at what the equation is to understand how to answer this question. From the derivation, we know that for the satellite to escape, its kinetic energy must be greater than the gravitational potential energy. And the final equation for escape velocity is square root of 2gm over r, where m is the mass of the Earth, not the satellite, such that any of the mass difference in the satellites in the question does not impact any of the escape velocities. Applying this to the question, we know that escape velocity is independent from the mass of the satellite. For greater escape velocity, we have to consider the distance between 2 objects here, which is the Earth and the satellite. Looking at the equation, we know that the less the radius is, the greater the escape velocity will be. Thus, the answer for this question will be D. Final question here, question 14. Have a quick read through the question, and you'll realize that all of the questions I picked are non-calculation questions. So those ones are the ones that you can save time on if you prefer to do multiple choice during reading time. So we know that this question has talked about Module 6, electromagnetism, and the relevant dot point will be interaction between 2 parallel current carrying wires. Let's remind ourselves what this topic talked about, looking at this diagram here. With relevant equations below, we know that mu here is the permeability of free space, I here is the current, R here is the radius. But none of that would matter here as much, since we're just trying to use the equation to understand what the question is asking, because this is a non-calculation question. Now, applying this knowledge to the question, we know that reversing direction of the current in y, meaning that this force between two parallel wires will be attraction force. Looking at the diagram here, comparing to the question, we know that the reverse direction will mean that both currents are going the same direction, so it must be the attraction force. And the second part here, we must consider Ampere's law. Increasing the current in y will consequently increase the magnitude of the force, which is also highlighted in red below. Now, looking at the question here, we want to know which vector arrow represents the force on y-x. So we know that it must be an attraction force, so that the direction of the force must be the same as y. And we also know that doubling current in y will increase the force, so that the line of force must be greater than what is already exists in the question. This means that the answer for the question will be C.